Welcome to Rish Explains Math, specifically 2016 AP Calc BC FRQ question number 4. So, the first thing we're going to want to do is throw this away because this is a non-calc question. So now that we've done that, let's go ahead and take a look at the differential equation that we're given, which is dy dx. So we should know initially from there that we need to take it in terms of x, and then that is equal to x squared minus 1/2 y, and from there we're going to go ahead and try and figure out what 4a is asking. So that's asking us to give us a second derivative in terms of x and y. So the first thing we're going to want to do is we're going to take the derivative, and we go ahead and we get d squared y divided by dx squared equals 2x minus 1/2 dy dx. Are we done? No. As soon as we see that dy dx, we know that we have to back input the dy dx differential equation that we were given. And from there, all we have to go ahead and do is take a look at what dy dx is, and from there we can simplify if we'd like to. And if you simplify, your final answer will be 2x minus x squared divided by 2 plus y over 4. So let's take a quick second and look at the next problem. Let y equal f of x be the particular solution to the given differential equation whose graph passes through the point -2, 8. Does the graph of f have a relative minimum, a relative maximum, or neither at the point -2, 8? Justify your answer. So, if we want to see it has a max or min, we need to make sure that dy dx equals 0. And in order to see if it's a min or max, we have to see if it's concave up or concave down. So, the best way to do this is, since we already have dy dx, and we found d squared y over dx squared, we can actually just go ahead and plug those values in. So let's go ahead and scoot down to b. And as you can see here, I plugged in the values for x and y, and I got 4 minus 4 equals 0, and for d squared y over dx squared, I got -4 minus 2 plus 2, which is -4. So we found that dy dx equals 0, and d squared y over dx squared equals -4. So, since it is concave down, and it must be a relative max. So, our justification here is, since dy dx equals 0, and d squared y over dx squared equals -4, the function f is a relative max at the point -2, 8. It's important to specify that you're talking at which point, because it could vary depending on the point. So let's go ahead and take a look at part C now. Let y equal g of x be the particular solution to the given differential equation with g of -1 equaling 2. Find the limit as x approaches -1 of g of x minus 2 divided by 3 times x plus 1 squared. Show the work that leads to your answer. So, this could be, as people call it, the hospital rule or L'Hopital's. I prefer if you call it L'Hopital's, but let's go ahead and start looking at if L'Hopital's would apply. So the first step that we're going to want to do is we're going to want to see if the top and bottom both go to 0. So we're going to plug in -1. G of -1, as we determined, was 2. And, sorry, just making sure you can see here. And 3 times x plus 1 squared will also be 0 there. So we can go ahead and L'Hopital it. We take the derivative there, and we go ahead and get g prime of x divided by 6x plus 1. Instantly, since I know g prime of x is that x squared minus 1/2 y, I can set those two equal to each other. And then, since we are given the point g of -1 equals 2, we can go ahead and plug in y equals 2 and x equals -1. -1 squared is 1, 1 minus 1 equals 0, and then on the bottom here, we just have to plug in -1 and we see that's 0. So we take the derivative again, and we go ahead and get a very fancy answer here of limit as x approaches -1 of 2x minus x squared divided by 2 plus y over 4. Where have we seen that before? Oh yeah, that's just our d squared y divided by dx squared. So we would just plug in those same values that we did into dy dx, and since we have 6, we know this would be our answer. So this is -1/3 It's important to make sure that you show the different steps. So like split it up here, split it up here. And yeah, it's a pretty straightforward L'Hopital's problem. Let's go ahead and take a look at D. So for part D, let y equals h of x be the particular solution to the given differential equation with h of 0 equaling 2. Use Euler's method starting at x equals 0 with two steps of equal size to approximate h of 1. So instantly we know that 1 minus 0 is 1, divide that by 2, so 1/2 will be our step size. So we know 1/2 will be our step size, and let's go ahead and get the first slope. So we can use this point, x equals 0, and minus 1/2 times 2. So we get -1 will be the first slope. So we can go ahead and take a look at our first equation, which is right down here. And we see that we get y minus 2 equals -1 times x minus 0. And that's in point slope form. We go ahead and plug in 1/2 due to step size. And we go ahead and get 3/2. So our next point will be 1/2 3/2. So let's take a look at this differential equation right here. X squared minus 1/2 y. So we can plug in 1/2, and we get 1/2 squared is 1/4 minus 1/2 times 3/2, which is 1/4 minus 3/4. So that will be -1/2. And as you see, we then plug it in into this point. So we get y minus 3/2 equals -1/2 times x minus 1/2, and we're plugging in x equals 1. So there you can see y equals -1/4 and plus 6/4, which I just converted using the least common multiple of both, and you get 5/4 as your final solution. So you would get one point for using Euler's method properly, and 1 point for using for getting the right approximation. This is just my work here for finding the slope right here. So that's AP Calc 2016 BC number 4. Thank you, and I hope you guys have a great day.